So the series of events that brought me to Maker Faire today started with a phone call from an unknown Canadian phone number. And listening to the voicemail, I had never heard a voice sound so urgent, yet so cool and relaxed at the same time. It was the CBC, the Canadian Broadcasting Corporation, wanting to know if I was available for an interview for a national news segment in literally 15 minutes, not for some groundbreaking software engineering breakthrough, as my college self might have hoped when I was studying computer engineering. Give us a minute with the slides, please. Dramatic pause for effect. Great. But because I made an animatronic rat and put it on my head, hello, Maker Faire. Thank you so much for having me here today. My name is Christina Ernst, and I am the creator behind the social media account SHEBUILDSROBOTS. My content combines fashion and engineering to spark girls' interests in circuits and coding through a fun or artistic lens, like you just saw with my Remy from Ratatouille robot. The story of SHEBUILDSROBOTS started at a college hackathon when I was in school for computer engineering. Those of you who have been to a hackathon know that these are caffeine-fueled, no-sleep weekends of messing around with technology. And I decided to take advantage of our beautiful electrical and computer engineering building on campus, and I soldered together this Bluetooth-controlled, color-changing LED dress. My first ever foray into combining fashion and electronics. So you could see it on the screen behind me. On the left is me presenting my project at the hackathon, and on the right is me modeling it in my dorm room. So you can see that this isn't exactly groundbreaking, but it's fun to wear to a college Halloween party, and this was 2017, you have to remember. But when the hackathon weekend was over and it was time to present my project, something unusual happened. Coming up to my booth was girl after girl after girl asking the same question. Will you teach me how to code so that I can recreate this dress? After I showed one girl how to type the command on my laptop to change the dress from blue to purple, she said, "This makes me feel like I'm coding for real. This makes me feel like I can do this." There's evidence that this feeling of empowerment is the rule, not the exception, when girls are introduced to circuits through a textile lens. American learning science researcher Dr. Kylie Pepler studied this in middle school classrooms. She found that when e-textile circuits were introduced in these classrooms, girls tended to play a greater leadership role than boys, and the circuits physically sat in front of girls 81% of the time. Those of you who are doing or have done breadboard work in school know how rare that is, right? To not have that breadboard snatched from underneath you. I could not stop thinking about this research, and during my next year in school, my senior year, I decided to create a whole curriculum of essentially circuit crafts for absolute beginners. So everything from writing your first line of code to wiring your first circuit, all the steps towards a greater artistic or fashion-based project. And all of those projects are still available on my website, shebuildsrobots.org, today for beginners of any age. So these projects and these tutorials are all well and good, but how do we reach students whose schools don't have the funding for a set of fancy new engineering prototyping materials? How do we reach adults who might be passively curious about coding but have no intention of a career change? I believe the answer lies not in any one international effort, but in communities. My first ever experience with community making was in Urbana-Champaign, where I went to school at the Community Fab Lab. And my next experience was with the Chicago Public Library in Chicago, where I live, at the Harold Washington Main Branch Library. So for those of you who haven't been up to Chicago, the Main Branch Library sits at the junction of 6 train lines where it's accessible from virtually all of Chicago's 77 neighborhoods. And on the 3rd floor sits this unassuming neon green room piled top to bottom with everything a maker could need. So you've got your sewing machine sitting next to the 3D printers, and there's usually a group of 60-somethings learning how to use the laser cutter in the corner. This is the Maker Lab, a free and public place to learn and create. I had the honor of spending 3 months as Chicago's Maker in Residence after I was done with my day job at Google, so this was weekends and evenings, and I supplemented their existing programming with my own free weekend classes on circuits and coding. It was here where I witnessed the transformative power of public tools, and training uncoupled from any school's science department budget or PTA budget. On any given day, there were, college students working alongside senior citizens, all coming together to learn and create. Now, by far the most popular equipment in the lab are the sewing machines and the embroidery machines. To me, this illustrates the power of fashion and textiles as a vehicle for interest in other types of making and engineering and scientific thinking, such as coding and 3D modeling. In fact, I always say on my channel that the sewing part of what I make is just as much math as the engineering parts. And I bet we have a couple fiber artists in the room today. Could you raise your hand if you sew or quilt or knit or crochet or any really fiber art? Yeah, plenty of you. So you all know then that these things are algebra. They're geometry. They're spatial thinking. Yet there's this really prevalent phenomenon in my comment section that perceives my work as less technical the moment it becomes pretty. So I'm using all of the same microcontrollers, power sources, APIs, as the dudes who are building like bus tracker displays for their apartments. And no shade to bus tracker displays, they're awesome. But as soon as I add fabric or rhinestones and present it in that fashion context, the work is kind of devalued and perceived as less technical. This is even more interesting to me because the history of the computer is textile history. To say that fashion is divorced from the sciences is simply historically inaccurate. And that's because in 1804, the jacquard loom transformed humanity's ability to mass manufacture patterned cloth through the use of punch cards. Either a hole or no hole indicated to the loom how to carry out its weaving. This binary option of either a hole or no hole probably sounds familiar, and that's because it is the foundation for modern binary computing. Mathematician Ada Lovelace took this idea a step further, proposing that these punch cards could be used to represent any data. That is so profound to me that a woman could take what she knew about the textile technology of her time and use it to invent a computer program before the computer even existed. And I have no doubt that the people in this room have that same ability to look beyond the technology of today and to see the possibility of tomorrow. But it's really important that you don't explore these big ideas alone. A recurring theme I noticed with the classes I taught at the library are that the people who got the most out of my material are the ones who are most excited to share it with their social networks. And I mean their in-person social networks, not online. For example, one time after teaching a class on how to sew LEDs into fabric, a quilter came up to me with her idea for an LED constellation quilt and was going to essentially recreate the class I taught today with her entire quilting circle. Another time, just hours after a class, I got a text from a Girl Scout troop leader who was putting together a supply list for her girls to earn their robotics badge. I was inspired by the enthusiasm of these women, and around this time is when I started posting the behind the scenes of what I make on my social media. Everything from a responsive Venus flytrap hat to a glowing candlelit cathedral skirt with LEDs that I had programmed to flicker like candles. The response to seeing the kind of experimental trial and error nature of this work was really, really positive. And within a couple of months, I went from sewing alone in my bedroom to getting flown around the world to speak at events like today's about what this all means, about why combining tech and fashion is so much more effective at capturing attention and eyeballs than just tech or just fashion. And to be clear, I do not believe that this is like the fashion of the future, right? I certainly don't want to be strapped to a battery pack all day. These designs aren't meant to be, mass manufactured or sold or really even seriously worn. They're designed for wonder and whimsy and to show fashionistas that there is a place for them in STEM. And again, to be clear, I am not implying that the STEM gap is the greatest issue that our women and girls face. In the words of American activist Angela Davis, I refuse to reduce a politics of liberation to a politics of fashion. But I also refuse to trivialize the power of fashion and costuming as a vehicle for interest in making and engineering and greater scientific participation. Something about what I do was compelling enough to inspire these articles behind me, to inspire CNN to come film a mini documentary about my work at the library, to inspire Marvel to want to partner with me to promote the launch of their engineering-themed TV show Ironheart. And I really believe that is a testament to the outreach power that blending tech and fashion can have. So for the last part of this talk, I thought I would stop pontificating and get into some of the interesting engineering details about what it is that I make for you nerds. So every time that I start a new project, I have to ask myself this question. How can I get the maximum movement for the simplest components? And simplest here is a shorthand for a couple things. Smallest, yes, but also cheapest, most lightweight, and reused or recycled if possible. So with that question in mind, here are some of my favorite tools. First up is fishing line, a cheap way to get a lot of movement easily. I used fishing line in this final project for Chicago Public Library, where I made this dress inspired by a phoenix with these moving phoenix tail feathers all over the skirt. And we'll see if we can get it to play for you. But I could have included a motor inside every single feather on the skirt, but that would have been heavy, expensive, complicated to wire up, time-consuming. So instead, I used fishing line to almost invisibly connect the tips of the feathers together and then used just a couple strategically placed servo motors to pull that fishing line through some sewable, tiny 3D printed channels that I had made. If it doesn't want to play, that's okay. You can check out my Phoenix dress on my Instagram or on the Chicago Public Library blog. So it's not always the most complicated or expensive parts that can give you the most impact. And sometimes you're going to have to resist the temptation to throw the full weight of your maker knowledge or engineering education behind a problem when something simpler and cheaper will do. Next up are photoresistors. So some of you engineers already know that these are components that vary the amount of resistance in a circuit based on the amount of ambient light in a room. They're quite inexpensive. They cost about the same as a piece of gum. And although they technically measure light, they can be used as a proxy for many other things. For example, the proximity of a hand that casts a shadow. I used photoresistors in my responsive Venus flytrap hat that you just saw, as well as in that final project for Chicago Public Library, so that patrons could trigger the movement of the dress by putting their hand up to the glass display case and covering the photoresistors. So both of these favorite tools of mine are to say that although the ceiling of wearable tech can be very advanced and very expensive, the entry level really doesn't have to be. For less than the cost of a pizza, a group of students can experience the magic of waving their hand over a circuit that they built and watch it come alive. That intersection of learning and magic is exactly where my work sits. And probably why many of you came to Maker Faire today, because you felt magic. The first time you wrote a line of code, the first time you rendered a model, the first time you looked under a microscope. But here's the secret. Magic is not something we can create alone. At a time when science itself is under attack, we have to invite others into STEM and making in a way that feels joyful. We have to increase the scientific literacy of the general population by whatever means work, even if they feel silly or corny or frivolous. If my work can only reach teen girls with a fashion complex, then my work has reached teen girls with a fashion complex. And I believe that meeting people where they are is a key component in how we get back to a society that values scientific innovation. I know my community, and you know yours. So bring making and engineering into those conversations in a way that feels authentic to you. Because being at Maker Faire surrounded by all this good energy reminds me that making is fundamentally the discipline of hope. That even as our funding is being cut by the government institutions that are supposed to champion us, your work cannot and must not stop. Fashioneering is just my way of inviting other people into that world of hope. So next time you judge a science fair or talk to your niece or little sister about her math homework, I hope after today you feel empowered to bring art and fashion and design or whatever sets your soul on fire into the conversation. And together, I can't wait to see what you build next. Thank you so much. My name is Christina Ernst. Have a great Maker Faire.
What are you working on next and what's inspiring you going forward?
a long notes app on my phone of a couple projects that I'm juggling. The one that I would love to land next week is something inspired by the Met Gala. That's an ultimate ambition of mine, is to bring some of this interactive tech fashion to the Met Gala. So, little sneak peek, that's what I'm trying to land in the next couple weeks. And then I also have a couple different projects going inspired by fantasy and nature. So I've got a moving fish dress in the works, and then I've also got a dress that has proven to be quite a challenge with these wearable sewing machines that really feed fabric through the machine to make it like the illusion that the dress is sewing itself. So each present a lot of unique engineering challenges, but it's been really fun to play with some new materials to try to make these different designs work and to really level up my maker skills through doing these projects that feel very whimsical and fantastical. Thanks for the question.
Hello. What's the most challenging dress that you've done so far?
I think the very first project that I posted about on my Instagram, the one that kind of propelled me into virality, was this Medusa-inspired dress that I made. So the concept was going to be that it had snakes all over it. It would use some face tracking to point the snakes at you. And this was kind of an interesting period for me where my ambition far exceeded my skill. And to be clear, I'm still in that period, but this was like my very first foray, and I would post about this project in series, and because it was getting so much traction, people's expectations for the project really was going up beyond, my own just like very hobbyist experimental abilities at that time. So I was learning so much every single day. I was spending a couple hours after work on this project, learning how to programmatically generate models and use new types of motors and do face tracking and make, sewable mounts to put dowels on the exterior of a dress. Like, who has thought about the physics of what direction gravity needs to move in when your dress is down versus at an angle, and then you're trying to put some rotating snakes on them? So that was so many challenges at once, but it was really rewarding to just upskill so quickly from kind of this pressure that I was putting on myself and that the internet was kind of putting on this project to see it through to completion. I think there's a good chance I would have given up if I hadn't been kind of doing it for an audience. So in some way, making with an audience in mind has really forced me to upskill myself and develop new skills in a way that's been really rewarding. Thanks for the question.
I really like all the work you've done, like bringing like classes to students in STEM education, and it seems like you have a lot of experience with that. So I'm curious what you think in terms of designing the education experience for the kids. What problems have you been solving for them, and which problems have you seen them really connect with to give them the challenge that they need to learn, but also making it easy to be engaged?
Yeah, I found that the project that really needs to be pre-solved before the students touch anything is all of the tech stack has to be set up and ready for them to work. So maybe you're working with breadboarding and Arduino. You got to test those breadboards, make sure they're working. You've got to make sure the upload function on the Arduinos is ready to go. Those can be kind of finicky with getting serial ports connected, because having those moments of friction the very first time you're trying something really discourages students, especially in my experience, girls. Like, if their first shot just doesn't work, they go, oh, I'm really bad at this, I'm clearly not talented at this, I'm not going to do it. So doing as much as you can on your end as an educator just to make sure it's really smooth as it can be for the students is the problem that I like to pre-solve. The problem that I like to put in front of not just younger students but adults too is, after we learn the basic materials like blinking and LED, try to give them a custom challenge, not just, something that where everybody's going to have the same result. But I like to challenge them to encode some Morse code with a special message, because then they feel a little bit more ownership over, what they're blinking on their LED. It's a little more fun for them, makes the problem have a purpose, but also builds those fundamentals that they just learned. Okay, we learned how to blink an LED, so now we're going to learn about time and pacing and how to use that with the Arduino. So, yeah, thanks for the question.
How does that dress move?
You want to see? All right, so this is a dress that I sewed out of a tablecloth that my local bridal store had put in the dumpster, but I did wash it, and then I did dye it. And then I got this belt from the thrift store underneath. Sorry, it's a little hard to hold the mic and pull the dress up. Thank you. So we've got a belt underneath, and I've mounted two Dynamixel motors, which are like dual-axis servos. I chose these because they can have the double-axis motion, but also they're quite compact, and they're lightweight enough to fit on this belt that I sewed them onto. And then I custom printed some 3D mounts that attach to dowel rods that are just from the hardware store. And finally wrote just a little bit of code to move those motors. And yeah, you can watch it twirl. It's plugged into the wall right now, but you can power it from a 12-volt battery pack that I wear in a little custom sewn pouch that I just wear on the belt behind the dress, so you can spend a couple hours at the party with your portable rechargeable battery too.
As much as this challenges your lens through tech, how did it challenge your lens through fashion? And obviously there had to be a growth expansion for how you sew and how you build, and how did you learn that side better?
Yeah, the fashion side is totally self-taught for me. I wanted to be a fashion designer, ended up majoring in computer engineering instead, so that's how we are here today. So a lot of trial and error on my sewing machine. And it has been an interesting journey to see that, because I have that engineering background, those are the parts that I really feel like I can make a professional result in, but when it comes to doing the design, I'm like, oh, this is kind of hard. I see why these fashion design majors need to go to school for this. Making it all come together in a way that's flattering and is cohesive with the vision of the tech side that I'm doing has turned out to be more of a challenge than I expected. So huge respect to those with the design and art brains who make these designs happen in the world. But yeah, it's been fun learning new construction techniques as well. I think that's an engineering-y, mathy side that a lot of people who don't work in textiles overlook. But so much geometry, so much math, a lot of precision, measure twice, cut once, goes into the whole sewing process. So I think it's a really nice complement to all of the math that goes on with the engineering side. Thanks for the question. Awesome.
Well, thank you. Give a big round of applause for Christina Ernst.
Thank you so much.